Okay, so this is redox reactions, and this is basically using oxidation states in a reaction. Okay, redox stands for reduction and oxidation. Redox, reduction, oxidation. Because in a redox reaction, we get reduction and oxidation happening at the same time. Okay, one element will be reduced and the other will be oxidized. Or we can get the same element being reduced and oxidized in the same reaction. And if that happens, then it's called a disproportionation reaction. That's a special example. Okay? So this isn't disproportionation, this is just a normal redox reaction. And for the first step, all I'll do is write in my oxidation states, or my oxidation numbers. So let's go for those 5 simple rules. Do we have any uncombined elements? Yes, we've got fluorine. So that must have an oxidation state of 0. And it's F2, so I'm going to put 0 down twice. Okay, now I can carry this across to here, and usually I put a dotted line, but I don't think it'll show up on the camera, so I've put a nice straight thick line. Now when it is combined with another element, fluorine always has an oxidation state of -1. So I can put my -1 here. Now thinking back to our rules for oxidation, the charge of the molecule has to add up to all the oxidation numbers together. So when I add up all these oxidation numbers, they should equal this charge. Now this charge is 0, so far the oxidation numbers add up to -2, which means my magnesium, to balance it out to 0, must have an oxidation number of +2. And again here, magnesium is an uncombined element, so we'll have an oxidation state of 0. So that's it, that's my oxidation state for this reaction. Now we need to look at which element is being reduced and which is being oxidized. Now the rule for that is oil rig. You've probably seen this at GCSE. Oxidation is loss of electrons, reduction is gain of electrons. Now electrons have got a negative charge, so the more electrons you have, the more negative your oxidation number is. So for example, fluorine starts off at 0 and goes to -1. That's got a more negative oxidation number, so that's gained electrons. Reduction is gain. So my fluorine has been reduced. Magnesium starts at 0 and ends at 2+. That's got a more positive oxidation number. That has lost electrons. Basically, fluorine stole them from the magnesium. So this has been oxidation is loss. Magnesium has been oxidized. So in this example, my magnesium has been oxidized and my fluorine has been reduced. Okay? Now, there's one other thing we need to know about, and that is oxidizing agents and reducing agents. An oxidizing agent is something that causes something else to be oxidized. Now, my fluorine caused the magnesium to be oxidized. So my fluorine is my oxidizing agent. And my magnesium caused my fluorine to be reduced. So my magnesium is a reducing agent. Okay? If you find that a little bit hard to get your head around, because you can't remember which way around it goes, I always remember it like this. Whichever element is being oxidized is the reducing agent. Whichever element is being reduced is the oxidizing agent. So if you're being reduced, you're the oxidizing agent. If you're being oxidized, you're the reducing agent. So it's a simple way to remember it like that. And that is redox reactions.